Oh, hi everyone, welcome back to my YouTube channel. And today I'm up with the next question of top 150 interview questions of the lead code. So let's get started with today's problem. And today's problem is reverse words in a string. We are given an input string S. We have to reverse the order of the words. A word is defined as a sequence of non-space characters. It means that it should be a continuous string, and the words in S will be separated by at least one space. Like, we have to basically, in this question, what we have to do, we have to basically reverse a sentence ignoring all the leading or trailing spaces. uh, as mentioned in the note, that S may contain leading or trailing spaces or multiple spaces between two words, and the returned string should only have a single space separating the words, and we should not include any extra space. So let's discuss the question. Let's discuss the test amongst one of the test case, and let's discuss the intuition and the approach that we will follow for the question. So let's get started. So I have already quoted the input, which is my S. Like, I have hi, I'm Harsimran. I have a leading space and I have a trailing space. And in my final output, what I expect is Harsimran space space hi. That's what my final output is. I have already removed my trailing and the leading spaces. So as we can see in the above question, the very simple solution that comes to our mind is like, hey, just track all the words, insert all those words in the stack, insert hi, and Harsimran in the stack, and then just pop out all of these words, concatenate these words in the final string, and then just add the space. Fair enough. And I think it seems to be a pretty simple solution. And the it's high, not simple. It seems to be a pretty simple solution, easy and super duper solution, and that's all we could do. And the time complexity in order to find each and every word in this string is order of n, and the space complexity is also order of n, as we are using a stack over here, which will actually help us to track the number of words that we have in a sentence. But this solution seems to be a happier solution in the normal scenarios, like whenever you're solving for the sake of fun or for the sake of practice. But the moment we get this question in an interview, the interviewer will not be happy with this factor, with this extra O of n of space. So let's just move towards the optimal solution for this. So let's just discuss the same. Yep. And stack solution is over. I think it doesn't need too much of more discussion. So what type of pattern have you observed in the stack? You're inserting a hi, you're inserting an you're inserting a Harsimran. Right. Fair enough. We are inserting all of these words. How we are inserting? See, rather than what I thought of doing in the optimal solution is, I have a final string result which will actually store my final answer, and it's initially a null string. So what I think for an optimal solution is that, hey, rather than just clubbing all the things together in the string, why don't we modify the string, modify my result each and every time whenever we encounter a word? So suppose I have, at first instance, when I'm iterating from my, let's suppose I start my from 0 and I move up till it doesn't reaches the n, and let's assume that I got some word. But before taking out a word, let's just remove all the leading and the trailing spaces. Okay, so let's assume that my I is always less than n and my s of I is equal to a space. So I will simply increment my counter to I plus plus, and whenever I have something like I don't have any space, I simply track my words. Simply let's store my word in some string w, which is initially null. Now let's assume that I store all of my words in w, and rather than just storing this w every time directly in my result, rather than just doing this step every time, why don't we just change our string, the result, as w plus some space and plus the initial value of the result. We can do something like this, because in this way what is happening is that whenever what I'm trying to say is that whenever I try to, I've figured out the word which I have in my string, and after figuring out the word, I just try to append that word in my result, append that word before this, something like this, and then just modifying my result. That's what I can do at this point, right? So this is, I think this seems to be a fairly good solution at this point, but yeah, we need to just consider a few edge cases at that point. Like whenever I do not have anything in my result dot size is equal to 0, I'll simply update my result to w, and whenever my result or the else part is, the else for it is that I will simply update my result to w plus some space, and then I'll add the previous value of result. That's what I can expect. And one more thing that we need to keep in mind is, suppose I get whenever I'm traversing in the string, I get something like a space over here. Do you really need that? Do you really think that we need to add the space each and every time? The answer is no. So we can simply skip this. Because whenever I get a space, I am not even going into this while condition, and my string w is not getting initialized. So I can't really implement this operation whenever I get a space in between two words. So before implementing all of these conditions, I also need to check that if my w dot size, like the size of the temporary string in which I'm storing my words, is always greater than 0, then and only then this condition will get implemented. And this seems to be a fairly simple solution. Like rather than just reversing each and every character after all the operations, in this way I will get a reverse string after my while loop just completes, and we can simply return result. So this is the optimal algorithm that I came up after solving it a lot of times, and even after solving it, because even on the internet also we are given a lot of solutions, like implement something like reverse in between, reverse, like what on the internet what it says, it was a really complex solution that first take out the words, reverse that word, and then keep on reversing, then keep on storing the reversed words in the final answer, and then just reverse the final answer. I think it seems to be a pretty long solution, but rather this is a really optimal algorithm. In this we are not even using the reverse function, which is an inbuilt function. We are actually getting the reverse string by the end of the while loop. So that is what the beauty of this algorithm is. And the time complexity involved in this algorithm is big O of n, and the space complexity involved is big O of 1. So I think this is one of the most optimal solutions that I can give to this problem. Like, this was all, I think, if I say I didn't got at the very beginning, but after solving a lot of times I got this algorithm. So this is what I have researched from my end. So now let's move to the code part of this question. So now let's discuss the code for the same. So what I've done is I've initially taken two variables n and I, and I've initialized my I to 0, n to s dot size, which is the size of the string, and I'm moving till the end of the string, and I've taken a string w. Let me initialize it to some empty string, and whenever I get a space, I'm simply moving forward. I'm not really concentrated over here, and whenever I don't get a space, I'm simply storing my words in my temporary string, and whenever my size of string, the temp, like I have a word, whenever I have a word, I'll simply check for my result, the final result that I already have. If my final result is initially 0, I'll simply insert my word in the final result, or else I will simply append my current word which I have got after the iteration. I will simply append that word to the first in the very beginning of the result string, and this is what the operation is, and then I will finally return the result. So now let's run this algorithm, and this is a really fast algorithm, I must say that. Okay, so now let's just submit it, check for the time and space complexity as well. So let's analyze the time complexity. It turns out to be big O of n, and the space complexity it also turns out to be big O of n. I don't know. Oh yeah, I've actually used the result variable, that's why it is. But yeah, you can even modify your I don't know why it has given big O of n, but it's big O of 1 only. Okay, just leave aside. But according to me, it's big O of 1 because I have to return some resultant answer as well. But why I took the result as big O of n, like this string result, it is considering this in the big O of n space. Never mind it. But the basic intent of this question is that we are not using any inbuilt library function, and also we are able to reverse the words in the string. That's what the intent of this question is. And I hope, guys, if you have understood this question, please do hit the like button, and if you are new to the channel, please do subscribe my channel. It would help me a lot. It would help me to motivate to make more such videos and to come up with more amazing algorithms for the questions. I can only request you to share my channel with all of your friends who are who need help for the DSA practices or for the algorithms. It would really help them a lot. And one last thing, if you want to connect with me on topics other than the DSA, please do connect with me on platforms that I've mentioned in the description of the video. And if you feel that I have missed out something, please do mention it in the comment section, and I'll be back with the new video as soon as possible. Thank you, guys. Keep watching my channel.